Okay, we're live. Today's talk is about FMEAs. For those of you that don't know what that acronym is, it's Failure Modes and Effects Analysis. It's a risk analysis tool, not to be confused with FEMA. A lot of people, when they're referring to this, they say FEMA. FEMA is a different acronym, same letters, but different order. FEMA would be your Federal Emergency Management Agency, which is a government organization, whereas this is a risk management tool. So FMEA. And the question came from my team. They were looking for some suggestions from my team for topics for the videos on Friday. If you have one, please put it in the comments below or comments on our channel in general. But the question was, is an FMEA mandatory for a 510K? And I think the consultant knows the answer, but they thought it was a great question because we get that kind of question from our clients. And so the simple answer is no, you don't have to provide an FMEA in a 510K submission. In fact, there isn't any specific risk analysis tool that you have to use for risk analysis for the FDA submissions, except for a URRA for human factors. And that's something new that came out in the December 2022 guidance, even though they've been requiring it since 2018. So what is an FMEA other than just a risk analysis tool? A lot of people will say, well, it's a bottom-up analysis. Well, if you don't know how to do risk analysis, you're probably not going to know what the difference is between a bottom-up and a top-down approach. But a top-down approach, we'll start with that first, like a fault tree diagram. A fault tree analysis or fault tree diagram, you start with what you experienced. An accident at an intersection is the outcome, and you work back to what were the causes of that. And it's a tool that you typically use for quantitative analysis. So you're trying to quantify what things contribute to the possibility of having an accident at an intersection. And the reason why I use this particular example, an accident rather than a medical device one, is because it's a very popular tool, and there are lots of great examples out there for how traffic engineers use a fault tree analysis to determine what the probability is of a different type of accident at an intersection and whether they need certain types of lights and traffic signals at that intersection based on the traffic patterns and the volume of traffic. So that's just one example of how you would use a fault tree. You start with what the result is, the accident, and then try to figure out what caused that. Same thing with medical devices. You have a complaint, you have an adverse event, you have a serious injury or death. That's the outcome, the result. What could have potentially caused that? And a lot of times we're not quite sure what caused it until we get the actual device back, and we don't always get the device back. So we have to do a little bit of investigation, and that's why a fault tree is so helpful as a tool for doing root cause analysis. So it's often a root cause analysis, not just a risk analysis tool. So that's the top-down approach. The bottom-up approach, you start with what the component failure could be. So any kind of a failure of your device, your system, your component, your subassembly, let's say it's a software failure, let's say it's a hardware failure, you start with that failure and you work your way up to what it can cause and what the probability of occurrence is part of that, what the severity of the effect of the harm is, and what is the detectability. Now, a lot of people out there have learned, well, if you're doing a traditional FMEA analysis, you have three factors you consider. Probability, well, we'll start with severity first, severity of harm. Second, probability of occurrence of that harm. And third, detectability of that. So what is detectability of the defect or hazardous failure of some kind. So that's what the three factors are that are classically used in an FMEA. And that's how I was trained to use them actually in the automotive industry before I even jumped into medical devices in 2000. But when you come to the medical device industry, back in 2007, when they introduced the second version of 14971, they said it isn't best practices to include detectability in a design FMEA. And the reason why is it's too late to have, oh, it got hot, it's going to burn my hand. It's too late when it's in the hands of the user to have detectability be a risk reduction estimation that you're going to use in your risk analysis. So they want you to leave out the detectability for design of a device. However, in production process controls, which is another place where we use FMEA as a tool, you could have automatic detection by an optical imaging system or some sort of test that measures something automatically or manually. And so there you have detections occurring before the harm could occur, before it's in the hands of the end user or the patient. So in that case, it actually will act as a risk reduction. So therefore, when we apply risk controls that provide detectability to a production process, it's a risk reduction. When we apply detectability to design in the hands of the user, it's not going to reduce risk at all. So therefore, we want best practices to be 2-factor FMEAs or a design FMEA for design and 3 factors for process. But this still doesn't answer the basic question of why do we need this? When do we need this? What is this? It's typically an Excel spreadsheet. You start with identifying all the different things that can go wrong with the device, all the different types of components. You often organize your Excel spreadsheet in the different types of subassemblies or components or systems. Like you'll have a software section, you'll have a hardware section, maybe electronics. You might have usability section. You might even have a completely separate FMEA that's for usability. So they have what they call a use FMEA. You could look at it from the perspective of use errors, things that can go wrong from a user interface for the patient. You could go with things that go wrong for the user, like a surgeon, or you could have an OTC product where the patient and the user are the same. So there are companies out there that do use FMEAs. But what we're really looking at here is what the basic question is, do I need this? Am I required to do this? Well, anybody that is working in the medical device industry on design of a medical device should know that design controls are expected and risk management is expected. You need both of those. So 13485 clause 7.3 is the design controls, and 7.1 is where you have risk management. Those are both required. And so, no, you don't have to attach your FMEA to a 510K submission. The only places where you have risk management typically required would be software risk, hazard analysis, which doesn't include the probability of occurrence, and it doesn't include detectability, and use-related risk analysis, which also doesn't include probability of occurrence or detectability. So those 2 examples where you have to submit hazard or risk analysis, it's not really an FMEA that you're going to be submitting. So when do you need this FMEA and why do you need it? Well, if you're going to have an FDA inspection or you're going to have an ISO audit or you're going for CE marking, they expect you to have a risk management file, and that risk analysis is part of that file. But I think what people are really asking when is this mandatory, subconsciously, I think what I'm hearing here is, how can I get out of doing this? And I think that's the fundamental problem here. Companies want to get out of doing risk analysis. And why? Well, let's see. It takes too long. It's very time consuming. That's one of the things we hear. And we have some solutions for that. Number 2, they're saying it's not fun. I don't like it. It's tedious. So how can we, okay, maybe fun is a stretch, but maybe we can make it less tedious. Maybe we can make it value added. That might be possible. And then how can we get this done efficiently? Because the bottom line is, I want to get my product to market. And if I have to spend tens or hundreds of hours on building a risk management file, that might not be the resources that I have. How can I reduce the amount of work that's required for a risk management file, and specifically a risk analysis like an FMEA? So what can I do? I'm going to get to that in a minute, but I really want people to understand why people are trying to get out of this. I think this is really important. So this part, share this with your friends, and this will make sense to anybody that's trying to explain why we need to do risk analysis, why it's important, and why people don't want to do it. I think this part will really help. Number 1, People that are inventing things, designing medical devices, they like to build things. They're inventors, they're builders. So they want to build something physical. So that's the first part. Paperwork, not on the same scale of interest to them. Number two, they're willing to do drawings and specs. Why are they willing to do that, but they don't want to do the risk analysis part? Because the drawings and specs are typically integrated very closely with the manufacturing process. You have to, if you're going to 3D print something, you need to create a 3D model in CAD, in like SolidWorks or something. So they're very familiar with designing the device on a computer, and then giving somebody a 3D file, and then having them manufacture it from the file, whether it's being CNC machined, whether it's going to be assembled and manually produced, or it's going to be 3D printed, whatever the method is. They're comfortable creating a model on a computer and then having somebody manufacture it. And those two are often very related. You can't even 3D build something unless you create a 3D model first. So the building it and the drawing of it, those two they don't have a problem with. But then when you say, can you please do the risk analysis? Well, time out. That's not part of the manufacturing process, and it's not part of the building process. So I don't want to do that. That's stuff I don't like to do. So how can we make sure that these people do this? We have to convince them it's necessary. Well, let's go back to the premise that this takes too much time. It's time consuming. Well, I was looking at the chat, seeing if we had a question there. If you do have a question, put it down in the chat. So time consuming. If I don't do a risk analysis, I might forget a potential risk and not prevent that. And then I'm going to find out the hard way, and I'm going to have to redesign the device. So whatever time I thought I saved, when I redesign the device, that's not going to be a time savings at all. I'm going to have to redesign the device twice and potentially do my testing twice, because I'll probably find the problem in testing. So that's why we want to do the risk analysis first. You want to have traceability. You identify your hazards, you identify a risk control, which is probably going to be design or some sort of alarm for the system, or labeling. That would be your last priority. But design and manufacturing methods are the first priority for reducing the potential for a risk. And then once we've identified a risk control, then we're going to test to see if it's effective. So if you don't have traceability to, here's the hazard, and then next, and I should go from this side because we're mirror image here. So you start out with hazard, and then you go to the risk control, and then you have your verification test to show that risk control was effective. And if we don't have that traceability, the verification test over here, it wouldn't be acceptable anyway. But let's not find out the hard way by failing a test and having to redo our design and redo all the testing. That costs me time and money. So what we're trying to do is convince people it's valuable and critical that you go out and do your risk analysis before you finalize your design, because otherwise you're going to have to design twice and you're going to have to test twice. And that's far more painful than getting it right the first time. And you may have already taken for granted that it's impossible to design a device once the first time, but we could avoid doing it 20 times in a row for every single risk you fail to document and implement a risk control for. So you really want to make sure you identify those risks early. Now, how can we do that? How can we make the team understand the importance of this, other than just saying, I need you to do this, we need the paperwork? They need to understand we don't want to have this fail in our testing. So let's identify all the potential ways we could fail early and figure out a way to avoid those now. So one of the things you can do, we're not going to probably make this fun, but one of the things we can do is, if you have a list of all the tasks that you're going to do that are related to your risk management file, if you identify those tasks, all those risk management activities, we call them, then you can create a plan. You have like a Gantt chart or a list of tasks, and as you do each one, you check it off. Well, there is a little bit of satisfaction. Oh, we checked off another task. We only got 3 left. We only got 2 left. We're done. That is a little bit satisfying to a team to see the progress of the project move along. Certainly for the project manager, the design team leader. Number two, if you have a good facilitator that knows how to facilitate risk management activities, that will really help. So somebody that's done this a lot and knows how to facilitate the meeting, not wondering how to do it and struggling with it, yeah, they can be the resource for the whole team. That's really helpful. Somebody had a question here, really good question. Is the FMEA a living document? Absolutely. All of your risk management file will be a living document. Every single time you change it, you've got to update your risk management file. So if you have a risk appear that you didn't know about, you're going to add that to your risk management file. That's going to be added to your FMEA, and usually there's a revision date on the FMEA. So that's a great question. Um, if you have these meetings, make them fun. Give people something to drink. Give people a snack. Don't have them be really, really long. Don't have them in a really crummy room. I mean, some of the rooms that people have these meetings in, no windows, one door, hot, stuffy. Pick a better room. Pick a place where you can facilitate this. Have it be a fun environment. Put something creative out there to get people's brains churning, because they're supposed to brainstorm what are the things that could go wrong with this device when they're trying to identify hazards, for example. Make sure people have the resources they need. Make sure they have guidance documents that list the potential risks for a device. Make sure that somebody already has done some of the homework ahead of time. So you don't have to have one person do all the homework. One of the best strategies as a team leader, divide and conquer. You have different systems. That's why you have different team members. So you have a software system, you have a hardware system. You might have something that has a user interface. You might have biocompatibility. You might have sterility. Each one of these systems that you're going to have involved in the design of the device, you might have a specialist on your team. That's their job. Well, why don't you ask that person to focus on, come prepared with the standard typical risks that we see for this type of device for that system. So if each person has done the homework and already gotten the information they need for that system, then when you compile it together as a group, you'll have a very comprehensive risk analysis. If you have one person do that, it's unlikely that person is the genius that knows all the areas. Even though I'm cross-disciplinary and I've worked in a lot of different areas, there's still areas of weakness. Electrical safety and EMC testing, not my strength. So I really rely on somebody in that area to help provide risks that we need to worry about. I learn more and more each time I go through these sessions with them, but divide and conquer by specialty, and make sure your design team covers all those specialties. So each person brings something to the team, comes prepared, has the applicable guidances for their specialty. Facilitate the meeting really well, make it as fun of an environment as you can. Give them snacks, give them caffeine, give them a high quality room, and do not make those meetings too long. You're better off having several short meetings instead of one really long meeting. So those are my suggestions to try to make this risk management activity go smoother. But you should never expect to get all of it done in one meeting. You should never expect it to be a once and done activity. That question about, is it a living document? That's really key. These are updated over time as you identify new failure modes or new standards come around, or you make a change to your design. And now that we've facilitated this meeting and we've done the risk analysis, now we have something that we can put in that file. But for every single one of those hazards that we've identified, we should have identified a risk control. That's part of your FMEA. We had the three factors I talked about: the severity, the probability of occurrence, and the detectability, or if you're doing design, you drop that one. But then you have risk controls. So you're scoring things, you're prioritizing things based on the score, but then you got to identify, what are your risk controls? What design and manufacturing thing is going to reduce those risks? And that's where you really get into the designing of the device. And those things go into the CAD drawings that you're going to create, and will go into the prototypes that you build. Now, a lot of times we talk about in risk management, we talk about risk control option analysis. You're already doing that and you don't realize it. When you have two different design concepts, to solve a problem and you can't decide between the two, and you build two different prototypes and you evaluate both of them and try them out and see which one works best and put it in the hands of a potential user, like a doctor that is on your advisory board that's helping you, that's option control risk analysis. You are handing a prototype, two different design options, to a potential user that's representative of the actual users that you intended the device to be used by, and you're asking them which one of these is the better solution to this problem. That is option control risk analysis, but you're not calling it that because you're not doing the risk management documentation until after you're done with the design. The time to do it is when you're having that meeting with a person. You say, this is option control risk analysis. We produced two prototypes and we're getting their feedback on it. Maybe it's on usability. Maybe it's on ergonomics. Maybe it's on weight. Maybe it's on which one boots up faster. If you have two different software designs, which one will boot faster? Which one has the smaller file size? Which one draws the less juice so it drains your battery slower? Those are things that you're doing all the time. You're trying out different codes of software, different sequences to try to make the device function better. And that's risk control option analysis. You're just not calling it that. So you need to come up with a plan up front as part of your design project for all the risk management activities you're going to do. You need somebody facilitating the meetings, each of those risk management activities that knows risk analysis requirements and can help the team facilitate each of the documents you need for your risk management file. And you're already doing a lot of these things, you just don't know it. But if you plan up front and do each of these activities the right way, then you won't have nearly as many things fail in your testing. And that will save you time and it will save you money and will get your products to market faster. So this really has real world practical applications and value add for you. Now, some of the other questions that were asked here related to this, like when does the FDA need the FMEA or the risk analysis? If they don't put it in the submission, when do they need it? Do they ever even look at it? Yes, they look at it when they do inspections. And so the person that's doing the evaluation of a risk analysis and design in the Office of Device Evaluation during a 510K is probably a biomedical engineer, maybe a master's degree, maybe a PhD. They know design. They haven't actually worked in a medical device company in all likelihood, but they know design and they have the biomedical engineering background. The person in the Office of Regulatory Affairs, ORA, they're doing the inspection and they probably don't have a biomedical engineering degree. They probably don't even have an engineering degree. In fact, one of the better inspectors I've met, he worked at an orange juice plant. He came from the food side. And a lot of the FDA inspectors that do device and drug inspections, they come from the food side. And so they're not going to critique your risk management activities. They're going to be looking for, do you have risk management activities? Do you follow your procedure? So did you create it after the fact as a gap analysis of your documentation? Or was it part of your design process like it was supposed to be? So that's when they look at it. That's when the FDA wants it. Next, when do you create an FMEA? As I said, it's supposed to be done during the design process. The sequence is supposed to go plan first, hazard identification second. That's a design input, the hazard identification. Then you're going to estimate risks. Once you've identified the hazard, you can estimate these risks, estimate severity, estimate probability of occurrence, detectability for the manufacturing process once you get to that. And then you're going to do your risk control option analysis. And then you're going to finalize the risk control you chose, the design choice. And that's when you implement the risk control. It's when you have a design freeze and freeze that design. So the risk management activity or risk analysis activity, FMEA, occurs between the hazard identification inputs and the design output, design freeze. In between, in the middle of development, when you're going through iterative prototypes, that's when it's supposed to occur. Not after the verification, just before you submit to the FDA or just before you do CE marking. And then one last question was, is there more than one type of FMEA? Yes, there are multiple types of FMEA. I already mentioned a process FMEA. That's for a manufacturing process to try to reduce the risk of making a bad part. When we do a design FMEA, we assume every part is made to specification. But when we're doing a process FMEA, a PFMEA, we're looking at what is the probability of making a bad part in that manufacturing process. So very, very different use of the risk analysis. And the only thing that's different in the beginning is the letter DFMEA versus PFMEA. But the PFMEA will have 3 factors. The DFMEA will have 2 factors, and they're used for very different purposes. There's also use FMEAs out there. There's an FMECA, failure modes affects criticality analysis. There are some other ones out there as well that people have come up with, but those are the most common ones. We also had some other questions here. Here's a proposition: risk control can be the answer to eliminating detectability. In the design process, risk control is what detectability always was, if done correctly. No, it's not. A lot of people have suggested that over the years, a lot of people, but that's not the case. Detectability is you can detect that the device has failed. The verification tests, the design verification tests, and the design validation tests might be able to detect them, but don't always detect them. So we have in a process FMEA sterilization, we have all kinds of process controls that are mandated by the international standard that we're supposed to put in place as risk controls. But the test for those, we're allowed to use detectability. We're allowed to use PCD, a process challenge device, for detecting whether the process made a sterile part. We have something we can remove and test without damaging the product, because it would be destructive testing. We can't test that product. We can only test the PCD. But we can't do the same kind of thing for, is this going to result in a use error? We can do simulations. That's something we can do, but it's not going to be the same. In fact, that's why the FDA no longer allows you to even estimate the probability of occurrence for software problems and usability problems. So they want you to eliminate that column. And I know the engineers out there that are used to these 3-factor ones from other industries like automotive and aerospace, they're saying, yes, we can do this. And like, no matter how many times you try to argue this, they're not going to let you do this because it's not considered best practices. Now, you could use a different tool altogether. Use fault tree. That doesn't have detectability in it. Why not use that tool for your risk analysis instead? And I know probably my friend Rick doesn't really like that answer. And that is a suggestion that's been used by a lot of people, but it's not accepted by the regulators. Let's see. The next one was risk control is at least how can I detect detectability, a flaw or weakness in a design? Your testing that you're going to do, verification, it's presumably going to show you the effectiveness or completeness of your risk control. But that's not the same as detectability. Detectability in our traditional PFMEA is quantitative. And most of our design verification testing and design validation is qualitative. It passed, it failed. So it doesn't really give you a risk reduction at all that's quantitative. So it's not the same thing. You can't really have that same P column. D column, the detectability. So I know a lot of companies have tried that. A lot of companies have put that in as a suggestion, but that isn't what they're saying when you're doing the testing, your design verification testing. It's seeing, is there completeness in your risk controls? Are they complete? But that's not the same as detectability. I don't see any other questions there, so I think that answers our questions for today. But I'm sure some people will have some other comments on this. from how they've approached these issues, how they're using an FMEA, or how they were taught on it, because it's used by different industries. Medical device didn't invent it. Medical device cooperate, like stole it and used it their own way and modified it a bit, and that's how the DFMEA came about. I worked in automotive, and we used 3-factor FMEAs all the time for designing automotive. So, but it's not the same process. And so if you're doing the documentation for the medical device industry and you're submitting it as this is our risk management file, you got to comply with the 14971 standard. And that's what the standard is expecting you to do. I hope that helps people understand a little bit better about FMEAs, when to use them, and explains it's not required in a 510K, but you do need to do it anyway, and it will get inspected, and it will be needed for CE marking, and there is a value add in doing it during the design process rather than paperwork afterwards for paperwork's sake. I hope that helps, and please share this with others if you think it will help them. Have a great day. Bye-bye.